Alright, boys and girls, welcome back to the drive-thru. Special birthday shout-out to Nathan as we do a remix. This is the second or maybe third time I'm doing these videos. Let's hope they format right and we can move on. This is going to be a very important video because it's the foundation. This problem is going to be the foundation of this entire unit. Okay, so I encourage you to pause the videos and read this very, very thoroughly. You won't have to do it again, but you're going to need to know this as you move forward. Okay, so these are going to be called your constraints. This is your space constraint. And this is your cost constraint. And what a constraint is it's a limiting factor, a limiting set of circumstances. So it means that we can't just take 1 billion cats and dogs because we don't have enough room for them. We can't take 3,000 cats and dogs each because we don't have enough money to pay for their cat pens and their dog runs. Okay? Constraints are very important parts of inequalities. Okay, so we scroll on to the next part of the problem. And now we're getting into the part where they start to make their money plan. Okay, they're going to get $8 per day for a cat and $20 per day for a dog. Okay, they're confident they can fill all of their pets, so they've got to determine how many cats and how many dogs should they have. Okay. And it says, what do you think? What recommendations could you give Carlos and Clarita? So, I don't know. Maybe you want to focus on all dogs because you prefer dogs and they're more enjoyable for you, so you'll have more fun that day. You could say the same thing about cats. Maybe you prefer cats. Maybe dogs bring you more money in net, and you would want to do that. And so there's lots of different recommendations. I suggest you consider making one here, but that is in essence just an introduction to this lesson, this unit, okay? So let's come up with a space constraint equation. And I tell you what, for the rest of this chapter, we're going to let C be cats. That's going to be our x-axis. And we're going to let D be dogs. And that's going to be our y-axis. Okay? Just remember, it's going to be alphabetical for the entire chapter. So, what is our space constraint? Well, it looks like we have 6 square feet for each cat, 24 square feet for each dog, and we only have 360 total. Okay? So 6 for each cat plus, is it 24? 24 for each dog, and that cannot exceed, it has to be less than or equal to 360. In this case, square units is just a unit of measurement. It doesn't mean we square the 6 or the 24. What is a square foot, you might ask? On my screen that I'm writing it on right now, not on your computer screen, it is literally that. It is 1 foot by 1 foot. Now here's a question. How many square inches are in a square foot? So again, that's 1 square foot. How many square inches are there? 144. Let's act like it looked like that. That should be 12 by 12 there. So, these are square inches. This is about a square inch. So there are 144 square inches in 1 square feet. Okay? So that kind of gives you an idea about the space constraint. What about our cost constraint? Well, let's see. It's going to be $32 for each cat and $80 for each dog. So 32x plus 80y, and that cannot exceed the amount of money that we had left over from our last business venture, which I believe was $1,280. So it's got to be less than or equal to $1,280. Okay, these constraints are going to follow us throughout this entire chapter. Now let's look at some of your homework. Okay, substitute the given points into both equations to determine which ordered pair satisfies. Graph both the equations and label the point of intersection. So, let's see. We've got y equals 3x minus 2. Sorry about the x. And you've got y equals x. If I put in a 0 for this one, I get a negative 2 for this one. However, if I put a 0 in for that, I get a 0 for that. So it works for this one, but not for that one. Okay? If I put in a 2, I get 3 times 2 is 6. 6 minus 2 is 4. That does not work. If I put in a 2 for this, I get a 2 for that. And that does work. Let's see if we can find one that works for both. If I put in a 1, 3 times 1 is 3. 3 minus 2 is 1. It works for this one. Put in a 1 for x, I get a 1 for y. Alright, now let's graph the blue line. Okay? So, the blue line has a y-intercept of negative 2 and a slope of 3. So that's how I've chosen to graph it. You could just make a table of points is another really good way to graph it. Let's graph this line. Okay, now let's graph the line y equals 1x plus 0. 1x plus 0, so 0, comma 0, 1, comma 1, 2, comma 2, 3, comma 3, 4, comma 4, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, all the way up to the corner. Uh-oh. No, shoot, I went through the wrong one. That's not the origin. Jeez, Pete. There we go. There we go. Okay. And now look, this is the key to this little example problem. Where do they meet? They meet right there. At which point? 1, comma 1. There's only one intersection point for those two lines. Okay. I'll leave number 2 for you guys to do on your homework. Let me help you out with number 3. Now it says, just solve them by graphing. So let's call this one the red equation, and we'll call this one the blue equation. Desmos, or your graphing calculator, is a great way to do these. So y equals 1x plus 3. So our y-intercept is 3. Our slope is 1. Every time we go over 1, we go up 1. So there's our red line. Starts right here and goes down there. Okay, now let's do the same thing for our blue line. So y equals negative 2x plus 3. Oh, there's the point of intersection. Over 1, down 2, over 1, down 2, over 1, down 2, over 1, down 2. You get the idea? And you can see that the point of intersection is 0, comma 3. So that's the answer to the question. We'll do one more, okay? The theater wants to take in, let's see. So this one you just want to use your graphing calculator. Let's come up with two equations. Oh, no, okay, this is a different one, number 5. So $5 per children's ticket plus $10 per adult ticket has to be at least, so greater than or equal to $2,000. The theater can only seat 350 people. So let's find 5 combinations. We have adults, we have children, and we have money. Uh-oh. I hope this doesn't screw it up. So, what if we just did a simple one? Let's just do 350 adults and no children. Let's make it a adult-only show. Well, we would come up with $3,500. That might be our ideal situation. We'd make the most money. But that's not likely, you know. We don't really have adult shows because parents like to take their kids to see a show. So let's see, that'd be 200 times 10, that's 2,000, plus 150 times 5, and that gives you $2,750, which is enough. We just want to meet $2,000 goal. Let's have you guys come up with the next 3 options for your homework. Now, we need more help on this situation, so when you have a homework question, please bring it to me. Other than that, have a great day. Boom!